there's basically spaced out on the wall there. So we have 4 lessons in a row, then you got a quiz, and then on Monday, you got nothing, okay? And so we're actually going to shift it just a little bit. You're going to come back on Tuesday, we're going to review a little bit, maybe do quiz corrections if we need to. If we don't, just review. And then we're at 8-5, 8-6. We're going to review on Friday, and then unfortunately, your test lands on a Monday. Okay, and we'll talk more about that when we get there. But again, you don't have school on Monday, so it's kind of nice for you, nice long weekend. But it's a short unit, it's not too crazy. It is very heavily based on formulas. So you got to get used to using formulas, and if you do that, you'll be fine. Some of you actually might notice that you've done this before. You've seen this in chapter 1, way, way back. So do I expect you to remember it spotlessly? No. So I actually kind of teach it almost like you don't know it, but then I do make you do a few things because you have seen it before, like I said. So very first thing I want you to do is just jot down these definitions right here. You're writing that stuff down, and once we get that down, we can start cooking through the rest of the lesson. Chapter 8 is all about sequences and series. The difference being what we have right here is a sequence. If I put a bunch of plus signs in between them, it becomes a series. So they're very, very similar. That is the main difference. We're going to just start by writing an explicit formula, which is right here. Now, you've seen that before again, but we're going to fill those pieces in and just make sure we hit home a few of the details that you need to know. So first things first, when you're writing an explicit formula, I'm going to have an. It's comparable to y. So like when you write the equation of a line, you write y equals, and then like 2x plus 5. I have an, it's kind of like my y. I'm going to have a1, I'm going to put that in, which based off the sequence in front of you, what's your first term? 12. So you're just taking that number. So you put 12 in. Then I go plus, and it could be a minus as well, depending. But what number are we changing by? So we go 12, 16, 20, 24. So we're adding 4 every time. So I'm going to go plus 4. So 4 is like my slope in a sense. It's my common difference. It's my rate of change. And then I go, and I'm going to write n minus 1. And so that n is kind of like in x. All right, so it always shows up. It's like y equals 2x plus 5. We always have y and x. We are always going to have an and n when we write an explicit equation. Okay, so this represents that sequence. I could write the sequence out, or I could just write the explicit formula. They're comparable. The other thing that I want to point out is this one right here. I can actually adjust how I write this. I could choose to write this actually as 16 plus 4, but then I'd write n minus 2. Now, we always go with n minus 1, okay? In this class, we will always do that. But this still represents the same sequence. What it is saying is that 16 is my second term, okay? So if you have a different number there, that's what it would mean. And you're not really going to have that in here, but it's just something for you to be aware of. Now, we got to calculate. So calculate the 237th term. Explicit equations give you different terms. So I'm going to go ahead and plug this in. So I'm going to calculate 237. So n is the 237. So I'm going to change that. And then I'm going to have 12 plus 4. And now I put 237 in for n, and I put minus 1. What is 237 minus 1? 236. Okay, when you type this in your calculator, what I would recommend typing in, and you don't have to write this next portion down, is just type in 12 plus 4, and then put a parenthesis and put 236. Done. Or you can just put times, it does the same thing. So practice typing it in, because there's chances to make mistakes on this. And when you do type it in, what do you get? 956. Awesome. Thank you. A big thing about this chapter is just, what the heck am I looking for? What the heck do I know? Okay? So this is like letter B. It's like the bread and butter of this unit. We do this all the time. We have to do it if we're calculating a sum. We have to do it when we're calculating a term. It shows up all the time. Here, we're changing the premise of the question a little bit, but I'm still looking for something in my explicit formula. So now it says, which term in the series is 200? Well, which term would that be? I'm now looking for n. It is telling me that the last term that I'm looking at, a sub n, it's telling me that is 200. It's telling me to use my explicit, so the 12 plus 4. And now it's saying, instead of figuring out what the 237th term is, now I'm going kind of backwards. Now I'm looking for that n right there. So how do I find that n? There's actually multiple right answers to get started. I don't care how you start. There's wrong answers, so I care a little bit. But what would be one way of starting this problem to get n by itself? We are going to plus 1 eventually, but I can't do that yet.
You can minus 12. Minus 12.
Minus 12 is good. So I'll minus 12 to start. This is one option to start the problem. And so when I do that, you get this. What's the next thing you can do?
Divide by 4.
You can divide by 4 again, so that's good. And now I'm going to take that step of, let's add 1 to the other side. And when I do that, I get 48 is equal to n. So that means 200 is the 48th term. Folks, it's comparable to me asking you for the first question for letter B. It's like me telling you, given that x is this, find what y is. And then now it's like, given that y is this, find x. But now we're just using a, n, and we're using n. So it's just slightly different, but it's the same application that we've been doing. I'll slide back down. Is there any questions with this? Okay. Who can tell me, or who remembers something, given this as like something to prime your brain, something about Gauss? Anyone remember the story? So sad. So, if I asked you to add up the first 100 digits, you can do that just like that. And it comes down to this. You can pair things together. So we did this at the beginning of the year. We paired 1 and 100, and when I add that together, I get 101. If I go 2 plus 99, what do I get? I still get 101. What about 3 and 98? 101. So if I am following a sequence, and in this case when we're doing the sum of series, these are always going to add up. So what we can do is we can take our first and our last, and then if I go from 1 to 100, how many numbers is that? That's not a crazy one. How many?
99.
Not 99, because let's count them out. I would start off 1, 2, 3, 4, 5. So I'm going to have 100. So if I group them up though like this, I'm cutting that in half. I'm cutting the numbers in half. So I'd go 100 divided by 2. Now we're not actually going to calculate this, but we are going to generalize the formula. And so in general, our formula looks like this. The sum of this becomes our first term, which is a sub 1. And then I go and I take my last term, which in this case was 100, but so that's going to be plus a sub n. Notice how these things match up. And then I take the number of terms, so we use n to describe that, divided by 2. So this is the formula that we are going to use to find the sum of a series. Now, John is thinking, you know what, Nichols, that formula is all nice, but if I forget that, I'm just going to go 1 plus 2 plus 3 plus 4, and I'm going to add them all up, and I'm going to get the answer. What are you going to do about it? And what I'll do about it is I won't give you any credit. If I don't see this formula plugged in, you get nothing. Okay? Same thing with the explicit back here. If I ask you for the 237th term, I guarantee you that some of you are going to go ahead and start writing it out, and you're going to be like, I got it. And you know what, 9 out of 10 times it's wrong because you missed like the 171st term or something, and it takes forever. But I need to see the formulas. We're teaching you how to apply those. So please, 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 please make sure you do that. All right, we're going to calculate the sum of the series using our formula. So let's fill in the pieces that we know. What's my first term? 12. What's my last term? Count them up. How many do we got? 8 is good. Then I go divided by 2. Now, we got a lot of parentheses here. So what I will recommend doing is if you know 8 divided by 2, or what that number is, just write that down here as 4, and then I can go 12 plus 4 times 4 after I hit enter, and I should get my answer. So I want you to type it in, or do it in your head, however you want, but I want you to think about it, give me something for it, and then we will talk about it. What's the magic number here? Perfect. Thank you. 208. Questions? Oh. Yes, that is sigma. Yes, we get to talk about sigma for the rest of the chapter. You'll probably be asking what the sigma at some point, and that's all right. So, let's talk through it. How it works. So, sigma, summation notation, is telling me, without all of these words, calculate the sum of the series. That's what that is telling me to do. It's saying calculate the sum of the series that's given to me. And so, we read it like this. This is my starting point. So it's telling me to use my first term, or my third term, or whatever term it is, but it's telling me to start there. And so typically, in a textbook, you're going to see like I equals 1. We don't need to use I. We can use n and say n equals 1 or n equals 2 or whatever we want. And the reason being is because our other formulas use n, so I don't see the need to really muddy the waters for you there. But again, a textbook is going to use I. When we get to the top here, this is our end point, or the stopping. And so I would just have a number like 8 or 12 or 13, okay? And then lastly, instead of writing the series out, because you could write this out, I could do 12 plus 16 plus 20 all the way till 40. Instead of writing that out, we normally just use the explicit formula, okay? When we write, we are always going to put the explicit formula. So I'll have A1 plus D and then N minus 1. That's what we will always have there. We'll have it filled in. That's what we're always going to have. Questions on that? We're going to apply it now. So I'm going to leave that there so you can still write it. You get to draw your sigma. I'll draw a picture of yourself. Head shaking. You're just like that's terrible. All right, here we go. So I'm going to write n right here. And if I'm looking at this series, my first term is 12. But I'm going to put a 1 there to represent I'm starting by adding 12, and all the numbers going forward, up to how many terms is that again? It's 8. So I'm going to put an 8 up top. So I'm saying add my first to my 8th term up together. To represent this series, we basically just put that explicit formula, and so we're just going to have this. You wrote it already, so I'm not going to make you write it and tell me all those things again, but that's what it is. So this right here, when I see this, it is telling me, calculate the sum of that series for the first 8 terms. And there's no words there. But that's what it's telling us to do. Questions? All right, we got a few calculations, and then you're on your way to your homework packet. So I see sigma. First thing I'm doing, I'm writing my summation formula. So Sn equals A1 plus An, and then N divided by 2. So I need to find all these things. So explicit formula finds things for me. It finds the first term. It finds my last term. It finds how many terms I'm going to have. That's sigma telling me up there. So I'll deal with that in a moment. But my first term, I just take this 1 and I plug it in right there. I'm not showing any work right now because what's 1 minus 1? What's 3 times 0? So what's left? Well, 0, and then we go plus 5, so we get 5. So I'm just going to have 5 right here. I don't really need to see a whole lot of work with that unless the problem changes, which you're going to see down below. A sub n, this is really my 25th term. Realize that 25 is coming from right there. So I got my 25th term. So now I have to plug 25 in. So I'm going to have 5 plus 3, and then 25 minus 1. Let's calculate that and see what we get. Practice it. Make sure you can get it. What's that magic number going to be? 77. So I get 77. And I want to point one other thing out to you. You know, this n right here is 25, and that's 25. So I'm going to put 25 here. Now there's a little trick with those numbers we'll talk about later, but I have 25 terms, which is 90% of the time going to be that top number. So my formula is going to look like this. I'll have Sn equals 5 plus 77. And then I'm going to have 25 divided by 2. Let's calculate that, get an answer, and then move on to the bottom. $1,025. Good? All right, last one, a little bit different. So I'm going to do part of it with you, not all of it. So I look at this. I need to know my first term, my last term, in this case, my 23rd term, and n is going to be 23 as well. What's my first term? It's a trick. It's a trap. If I take 1 and I plug it in here, is that 0? No. It becomes just 3, so I get 245 minus 3 times 1, which just gives me 242. So if I look at the example above, it's an explicit formula, okay? If I look at this one, it's also an explicit formula, but it doesn't start with my first term. At the beginning of the lesson, I told you if I have a 1 right here, that means that is my first term. In this case, this is actually an I minus 0, which means this is my 0 term. We don't want the 0 term. We want, according to this, we want our first one. So I have to do that, okay? So that's why it turns out that way. Go ahead and calculate your 23rd term, and then see if you can calculate the sum given those two pieces. I'll start putting stuff up here as I go. What's the magic number? $4,807. Very nice. Questions? The last thing that I just want you to be aware of is this. I'm going to slide down just a little bit, so that's still there. You might actually see a series that looks like this. So if I get something like that, it just changes two things. Now, I'm still going to find a sub 1, the little quotes on it, Because a sub 1 is telling me my first term. It's telling me to use whatever the index says. So my a sub 1 is actually a sub 0. So I plug 0 in there to figure out that starting point. The other thing we got to watch out for is n. So in all the other problems, and 90% of your problems are going to be like what we had done. However, there might be an extra credit problem that's not like that. We've always said that's 20, or whatever that top number is. But if I'm looking at 0 right here, if I start at 0, how many terms do I actually have? I have 21. Because if I go 0, I go 0, 1, 2, 3. It's always one more. So then this would be 21. Again, 90% of the time, this is going to be a 1, and you're just going to take that 20 and drop it down. But for that 10% of the time that you might see it, or if you go to ELGE 3, you will see something like that. And in stats, they also do a little bit more with that. So I just want you to see it at least once. You can go to your homework really quick. And I want you to flip all the way to number 7, which is just on the next page. And if you look at number 7, it goes 2, then it goes 4, then it goes 8. What am I adding to get from 2 to 4 and then 4 to 8? Am I adding anything? Can I add 2 to 4 would be 2. 4 to 8 is 4. So I'm multiplying. So you actually just got to write that out to get the 8th term. And part of that is to make you realize that it's kind of a pain to do that. Like, it's not too bad because it's only the 8th term and you're given 3. But tomorrow you learn how to do that. So if you want, you can wait till tomorrow to come back and do that homework problem. Just don't forget it. Or you can just type it in your calculator and get it. So just a heads up on that. Otherwise, you should be good to go on the homework. Answer keys on the back wall. Please let me know if you got any questions.